In this video, we'll do a deep dive into using GitOps to deploy applications on a Kubernetes cluster. We'll start by reviewing what is GitOps and ArgoCD, followed by a demo on ArgoCD with an example use case of providing Atlassian Jira as a service to different teams or clients. DevOps is now a fundamental part of the digital transformation strategy for most organizations. As the development and operations team work in tandem, enterprises are able to deliver meaningful experiences to their customers at an unprecedented rate. However, complexity is increasing in the modern environment as deployments become larger, architectures are now more increasingly complex, and applications are deployed multiple times a day. GitOps is a process that is used for continuous deployment of cloud-native applications used to bring order to some of these complexities. It is built using the same tooling and technologies which DevOps teams already use, namely using Git as the operating infrastructure. Git becomes a single source of truth for all deployment automation. With GitOps, you gain many of the DevOps best practices, which include version control, collaboration, continuous delivery, and more, with the benefits ranging from better developer experiences, reliability, consistency, and now everything is self-documenting, so you gain complete audit trail and traceability of who made what change, why, and when. In Kubernetes, one of the more popular GitOps tools for application workload management is ArgoCD. ArgoCD helps deploy and maintain applications to these clusters. The typical workflow for developers is in the outer loops. They start by committing changes to a Git repository, which triggers the CI pipeline, which could be GitLab, GitHub, Jenkins, or anything else. The pipeline generates two artifacts. The first one is a Docker image, which is published to a Docker registry, and secondly, a Kubernetes manifest, either Helm chart, customized manifest, or even raw manifest. ArgoCD is continuously synchronizing these manifests from the published repository, and any changes will be updated to the underlying targeted Kubernetes clusters. ArgoCD also has a auto-heal functionality which detects drifts in a Kubernetes deployments and either alerts the user or auto-corrects them. Let's jump to the demo. This VMware Prod 2 cluster has ArgoCD deployed on it. Spectro Cloud provides an out-of-the-box integration for ArgoCD, which can be added to any add-on profile. We can access the ArgoCD UI. Once you log into ArgoCD, we can see the list of all the applications ArgoCD is maintaining on the clusters. There are two types of manifests being synchronized, both Git manifest as well as Helm charts. If we go into one of the Helm charts, we can go ahead and see all the configurations being pushed, everything from config maps, secret services, stateful sets, and everything else. Let's go ahead and add a brand new application. Select Add New App. Give it a name, Guestbook. Select the default project. Select Auto Create Namespace for the repository URL. And for the path, let's select Guestbook. For the cluster URL, we'll pick the current cluster and type in Guestbook for the namespace. Click on Create. If you go into the currently deploying app, you can force synchronization by clicking on Sync. Click on Synchronize. And now within a few seconds, you'll see the application coming fully up to life, where services are being deployed, deployments, replica sets, and all the pods. And now the app is fully deployed. Let's take a look at a slightly more complex example. If you go back to the Apps tab, notice this Apps. This specific application is what's called an app of app pattern, where this application lists other applications to be deployed and maintained by ArgoCD. There is this MySQL operator app, an NFS operator app, and a Jira Team 1 application. We can drill down into this Jira Team 1 app and look at all the different resources this app contains, from config map, PVC, secrets, deployments, and other constructs. What we would like to do is deploy a new instance of Jira with all these constructs for Team 2. We can go back to the Apps application and look at the repository GitOps ArgoCD. If we switch over to the repository and look at the Apps directory and go into Templates, all the 4 different instances of applications we saw, from Jira Team 1, the MySQL operator, NFS operator, are all listed here. We can go ahead and clone this Jira Team 1 YAML descriptor for Team 2. And then we'll go back to the templates directory, create a new file, and we'll paste it in, and we'll call this one jirateam2.yaml, and replace all the instances of team 1 with team 2. So 1, team 2, and team 2. If we scroll down, we can go ahead and make a commit, create Jira for team 2. Generally, we'd go through the collaboration workflow in your enterprise. You create a PR, your manager reviews it, you guys have a commit back and forth. In this case, we'll just directly commit it to the mainline branch. If we go back to ArgoCD, and then we go ahead and we refresh the state, you'll notice that it detects an automatic new application is detected. The sync will happen automatically, but it takes about 2-3 minutes. So we can force it by clicking on refresh. If I look at Jira Team 2, you can see all the constructs that are being created from the different secrets, the PVCs, the pods, and deployment. Jira is a massive application. It takes around 10 to 12 minutes to finish. And now the Jira Team 2 instance is fully up and running. It's synchronized and healthy. We can click on this icon to look at the application. And there you have it, using GitOps to provision and maintain your applications.